Here we go.
The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Welcome and thank you for attending G2 Integrated Solutions webinar, Creating Sustainable and Consistent Records for Class Location in High Consequence Areas. My name is Marissa Davis. I'm Marketing Specialist here at G2, and this morning I will be playing dual roles, one of which being the facilitator of the presentation, and the other, the bearer of bad news, folks. So, unfortunately and ironically, our presenter, Tracy Thorlifson, has fallen victim to the flu for a second time. For those of you who don't know or may have just recently registered, I say ironically because this webinar was originally scheduled for last month, but we ended up having to cancel it or postpone it at the last minute due to this exact same thing. So, Tracy, I don't know if you're listening from home today, but if you are, we hope you feel better soon and are able to get back to work, and make sure you're taking your vitamins, which really goes for all of you out there listening today, because I have heard that this flu is no joke. So there is my PSA for the day. The silver lining is that our co-presenter, Julienne Franco, who was initially going to take more of a support role, has stepped up to the plate, and she's ready to deliver the presentation today in its entirety. So, Julienne is a senior consultant here at G2 and is one of the original team members of Eagle Information Mapping before they became G2 Integrated Solutions. So, Julienne has worked along Tracy for a long time right now. Her role centers around maintaining client satisfaction and delivering software and service solutions. Julienne has worked in operations for Energy Transfer, as well as other major midstream companies, and Julienne really is just an integral part of our team here at G2. The host of today's webinar, G2 Integrated Solutions, delivers expertise to pipeline operators, utility companies, and other energy stakeholders in seven specialized service disciplines. We provide end-to-end solutions that help manage risk, assure compliance, and optimize performance. Our commitment is to implement innovative, cost-effective solutions that align specifically with our customers' needs. For more details on our services, please visit our website at www.g2-is.com. Oh, and real quick, we do have a large group today and we have a lot to cover, so we're going to save question and answer portion till the end of the webinar. So at any point during the presentation, if you do think of a question, if you want to go ahead and just submit it in the question box right there on the side of your screen, Julienne will be happy to answer it afterwards. Also, we will have a couple anonymous poll questions throughout the presentation, and we encourage you to participate in these interactive polls. With that said, thanks, Julienne, for saving the day, and I'll turn it over to you now.
Good morning, everybody. Once again, my name's Julienne, and I'm covering for Tracy today, and so I hope you all have some awesome questions at the end of the webinar. We're going to go ahead and start with today's agenda. We're going to cover an introduction to the associated regulatory requirements for Class and HCA, consideration for the selection and key components of class location and HCA software, and lastly, an opportunity to address your questions. Let's start today by considering class location and understanding population density throughout the various classes. Basically, the DOT class location uses an algorithm referred to as a sliding mile algorithm. The sliding mile output is intended to provide us with an indication of population density along the corridor of the pipeline. It's broken down into 4 different classes. Class 1 primarily covers rural areas. Class 2 covers more populated areas, or as we refer to semi-rural to suburban type areas. Class 3 covers densely populated suburban settings, and Class 4 is intended to represent an urban setting. In terms of pipeline incidents, an incident in a Class 4 location would be more severe than a Class 1. Specifically, what we are looking for is the population within the 220-yard or 660-foot corridor that surrounds the pipeline. We are looking for buildings intended for human occupancy. In Class 1, there are 10 or more buildings intended for human occupancy within a sliding mile. In Class 2, there are 11 to 45 buildings intended for human occupancy within the sliding mile. In Class 3, there are 46 prior buildings intended for human occupancy that exist. And also for consideration are sites that are likely extremely sensitive in terms of how they would be impacted in a situation. For DOT class, we call those qualifying outside areas or structures. They are areas where most likely people will congregate. For these types of qualifying areas or structures, we use a different buffer radius. We are using 100 yards rather than 220 yards. Any of these features automatically will cause a Class 3. Class 4, we are looking for a prevalence of 4-story or more buildings. With respect to HCA areas were introduced into the regulations of 2004, along with the pipeline integrity rule. Essentially, pipeline operators are required a higher level of scrutiny on portions of their lines that are identified as HCAs. PHMSA has given us 2 different mechanisms to determine HCA areas. The first is relying primarily on class location results. Essentially, anything that is a Class 3 or 4 is an HCA, with a caveat we'll cover later. For method 2, rather than relying on our sliding mile results, we calculate a potential impact circle, which basically is a function of the diameter and pressure at which the pipeline system is operating at, and is referred to the potential impact radius formula. Basically, a higher pressure line or higher diameter line results in a larger potential impact radius. The thing that method 2 gives us over method 1 is that with method 1, all lines are truly the same, in that a 6-inch pressure line results exactly the same as a 42-inch line. With method 2, the PIR is actually taking into account the likely potential impact circle of an ignited release. It gives you a better feel for the environmental impact. Under method 2, anytime you have 20 or more structures or a qualifying identified site within the potential impact radius, that qualifies as an HCA. Now going back to method 1, we are looking at Class 3 and Class 4, but for those of you who have a potential impact radius that is greater than 660 feet, you still have to pay attention to 20 or more structures within that larger potential impact radius, or an identified site within that potential impact radius. So if you have a large diameter, high pressure pipeline, you can't just ignore the potential impact circle. One of the things for discussion is a distinction between an identified site in an HCA and qualifying structures and outside areas within the class rule. An identified site for high consequence area analysis can be one of 3 things. We typically refer to these as type A, type B, or type C. The type A identified site is an outside area or open structure, much like the qualifying outside area you would apply to the class rule. There's a difference in terms of occupancy. In the class rule, the same restrictions apply in terms of 5 days a week in a 12-month period. Under the HCA rule, it is 50 days unconsecutive in a 12-month period. What this means is that under the class rule, I may have a baseball field that people only use on weekends, and it doesn't meet the 5 days of the rule occupancy, and therefore can be safely ignored for the class rule. However, under the HCA rule, if it is being used every weekend over the duration of the year, then it could easily meet the requirement, and there is no need to worry about 5 consecutive days. The definition of the qualifying outside area or structure of the HCA rule is more conservative than the class rule. Type B is a building like a business that is occupied by 20 or more people for 5 days a week for 10 weeks in a 12-month period. That part of the definition is the same as the class rule, and here we are essentially looking for structures that are occupied at the end of the day as part of the standard workday where people are outside of their homes. Type C are facilities that are basically difficult to evacuate. If you notice, there is no occupancy requirement here. Under the class rule, if you have a nursing home with 20 or more people, it will become a qualifying structure under the class rule. Here, if it were only 5 people, it would qualify. In this case, we are being more conservative. We encourage our clients to go ahead and even for classification classes, apply the same definition as the high consequence area rule.
All right, everyone, let's get to our first poll question. You should see it up right there on your screen. So to what extent do you feel comfortable or confident in your ability to maintain compliance with HCA determination regulations? So you've got a couple answer choices. We have a well-developed and robust solution in place. We maintain compliance, but it's always a challenge. Or we're not at a point to where we fully feel effective or efficient. So I'm going to go ahead and keep this open for just a minute or so while you get your votes in. All right, it looks like we've got about 70% or so of the votes in. Let me close the poll and share it.
Okay, so for the results on the poll results for A, we've got a 48% of well-developed and robust systems or solutions in place, a 43% ability to maintain compliance, but it seems a bit of a challenge, and 10% where we have some folks that don't feel that they're appropriately fully effective or fully efficient.
All right, moving on. Let's type this.
Let's talk about the type of things you have to do to identify an HCA, and also talk about why you do high consequence areas in addition to class location analysis. In terms of DOT class location analysis, we are actually using it to define the pipe material itself. And essentially what we do is grade the design pressure the pipe was designed to operate at a class location as class location increases. So the way you mitigate that is that you use a greater well thickness of the pipe. We use it both to define the design of the pipe, and of course, as time goes by and class location changes, it also has the possibility of impacting the maximum allowable operating pressure for your pipe. For high consequence areas, the primary purpose here is to identify those areas that actually get incorporated into your integrity management program. Essentially, high consequence areas are subject to more scrutiny than non-high consequence areas. Each time you identify a new high consequence area, you have to make sure to incorporate the high consequence area into your integrity management program. You will establish a baseline assessment plan for entering an HCA as it is identified. And you'll subsequently do the periodic assessments on that high consequence area as time goes by. With respect to the high consequence areas themselves, you will need to identify them as either using method 1 or method 2. That is referred to as class location or the PIR method. And in the course of normal operations of the pipeline, be on the lookout for an identified site that could cause a high consequence area on a pipeline. There's a number of things that will help you identify the potential identified site. The first is that a site might be on a list. We refer to those as using federal, state, or local authority lists for places that could end up being an identified site. Things like schools, prisons, and fire stations could be flagged as an identified site. So there's an indication that it is, in fact, an identified site. An operator is on the hook for identifying them. The key aspects of the source data for high consequence areas and class location is making sure that you properly identify all the identified sites that are potentially affecting your pipeline. Obviously, there have been stringent requirements with respect to identifying sites. You are also responsible for all buildings intended for human occupancy, both for high consequence areas and class location. There are a number of common operation activities that are going to potentially tag these structures for you that you have to go out and investigate. First of all, your routine line patrols, HCA patrols, area patrols, all those should be geared towards allowing you to pick up and identify structures that you need to add into your system. In some areas, you may have heavy ground cover. You may not be able to see farther than the right-of-way. So oftentimes an operator may augment the normal patrol data flow with a desktop study that is performed annually or more often, where you are looking at a variety of data sources trying to pick up anything that has been added or for consideration if it falls within the buffers of the pipeline system. Usually, you're looking at most recently available area or satellite imagery to pick up new structures that may have occurred or might have been put in place since the last time you did this particular exercise. Of course, this implies that you have somewhere a record of all your existing buildings intended for human occupancy or identified sites. You do that desktop study in terms of picking up new footprints for structures and potential identified sites, as well as interrogating the available federal, state, and local lists in the areas where pipeline centerline is present to pick up any new entries. The most important thing, even during a desktop study, even while using available lists and picking up things on area or line controls, are simply not enough. You actually have to go out and knock on doors to verify structure, type, status, and occupancy. A lot of companies use paper forms. In some cases, operators contract a third-party vendor to perform this collection. Here at G2 with our own operations staff, we'll go out to knock on all the doors and verify that a structure that was collected off an aerial photo is in fact a building intended for human occupancy and not a shack or barn, as well as picking up all potential identified sites and making sure that the occupancy meets the requirements under the definitions and that it is the type of facility that you think it is. The field survey aspect is a very important part of the overall process and a vital source of data for your class location and HCA analysis. Here at G2, we typically rely on the digital forms approach. Being that we are an Esri partner, business partner, we use applications such as Survey 123 and Collector for ArcGIS to perform digital data capture that can be pulled directly into GIS. Let's talk about the challenges that we face when performing an analysis. First, we always have to be aware of the fact that population is not static along the pipeline center lines. Those of us who operate in areas like the Houston metropolitan area, where growth is very rapid, are keenly aware that areas that might have been rural just a few years ago have now become suburban, having gone straight from a Class 1 to a Class 3. I live in Katy, and so that is in fact the situation. So keeping up with the new construction of residential structures and new construction of identified sites is in and of itself a challenge. If you are doing this type of work manually, where you rely on paper-based forms, or even if you're doing the analysis manually, then the effect of the data cycle time tends to snowball. If you're doing this process, for instance, maybe once a year, you may not pick up a structure that actually was placed until a year later. Under 192.611, you have 24 months to confirm or revise maximum allowable operating pressure on a line in the event that the class increases. So understanding the effect of the data cycle time on your overall business processes and regulatory requirements that are driving those business processes is very important. A lot of people rely on software to help mitigate some of the problems that a long cycle time incurred in terms of the workflows that support class location and high consequence area analysis for transmission gas pipelines. There are a couple of things that you might consider when looking at software. Certainly, it is something to consider when working with your data and software. When you buy software, you want to make sure it is flexible in terms of the data sources that it allows. You should consider looking at software that supports one or more standard data model like PODS, the ArcGIS data model, or the new utility and pipeline data model. You want to have some great performance. These analyses are usually quite compute intensive. You want to make sure that you are running software that is scalable and that can actually perform analysis on your system in a reasonable amount of time. This may be more important for larger operators than it is for smaller operators. But again, you want to be able to get actionable results in a reasonable amount of time. You want to make sure that your tool actually fits into your existing business processes and workflows, so you don't have to re-architecture your entire data management system to support an application you are going to be housing internally. Make sure that the software takes into account or helps out with fuzzy logic, so that if you have inaccuracy in the center line or inaccuracy in the structure surveys, that the software can deal with that and still produce reasonable and consistent results. We want to make sure that software can take in class location and high consequence area results from wherever you currently have them stored. And finally, a very important consideration is making sure it can perform change analysis over time. So it has to be able to consume what you already have for historical data. When dealing with class location and high consequence area analysis, integration, collaboration, and sharing are essential factors for effectively maintaining and keeping up to date the related records of the new structure and new identified sites. Okay, so let's talk about a few of the squishy terms that are present in the current regulations. So one of the things we want to bear in mind when using software or using computers to do this analysis is that computers live in a literal world. They do exactly what you tell them to do. The problem with this is the English language in itself is often imprecise. And in terms of the class regulations in particular, they are also imprecise. So we need to basically address some of the datedness in terms of the regulations. First, let's talk about cluster. So one of the issues with the class location algorithm is that the sliding mile can result in long stretches of pipeline where you're designated as a class 3, when in fact there are no structures present. The structures are clustered at either end of the sliding mile. So you may be designating a range of pastures, for example, as a class 3 when there is really nothing there. One of the details of the class regulation is that it allows you to perform what's called clustering, which helps you mitigate this effect where you have long stretches of corridor and there are no structures. Basically, what it says is that for a class 2, a class 3, or a class 4, we can end that class range within 220 yards of the last structure in that cluster. So what's a cluster? Turns out PHMSA has never actually put a concise definition to what a cluster actually is. How many buildings constitute a cluster? Is it 1? Is it 2? 3? What's a cluster? So one of the things you're going to want to consider when you're looking at tools to perform class location analysis is how does it deal with clusters? Does it give you the flexibility to allow you to define the clusters the way it's traditionally done? So that's going to be an important aspect of software selection. And finally, we talk about class 4s. The language that the regulation uses says that a class 4 location is where buildings with 4 or more stories above ground are prevalent. Well, prevalent is never actually defined. And so you need to have some mechanism by which you concisely define prevalence in terms of how your software is operating. At G2, we do it in a certain way. Essentially, we look at clusters of 4-story buildings intended for human occupancy. And within a cluster of 4-story buildings, we count the number of 4-story buildings. And we compare that count to the number of non-4-story buildings that are in that same cluster. And we allow you to set that threshold. So for instance, maybe you're going to say that with any given 4-story building cluster, if 51% of the structures are 4-story or higher, then we'll call it a class 4. So in that case, if I have 3 or 4 stories in my cluster and I've only got 2 other non-4-story structures, then it is a class 4. On the other hand, if I had 3 4-story buildings and I had 10 non-4-story buildings, it would only be around 30%. So it would not be considered a class 4. What you want to consider very carefully is choosing software based on how it will do the class and HCA analysis. One of the last things to look for in software, you want software to interact in whatever your system currently is, without necessarily affecting your data that is in there until you tell it to. You very much want to make sure that the software package is tracking what occurred and when, so that when you perform an analysis, you know the date in which it occurred. The way you can tie it to the state of, you can tie it to the state of the enterprise data source. We want to make sure that you're recording appropriate metadata about the information that goes into creating a particular result. For instance, I want to know which site is caused by a particular HCA, or which set of structures are causing a particular class. And is it in fact just a large set of structures and an HCA, or and an identified site, or simply an identified site causing an HCA? At G2, we actually go ahead and expose our tools for this analysis as ArcGIS geoprocessing tools. Basically, that means is that you can go ahead and actually modify the way the software works. You can run it on desktop, or you can run ahead and serve it up as a geoprocessing service. The important thing is to make sure that whatever you're doing, that you have sufficient flexibility to support the workflows within your organization. Let's close with our final poll questions.
Great, want to advance it. All right, our closing poll question is, do you feel that your decision-making and action planning resulting from HCA analysis is cloudy at best, compliant with minimal requirements of the regulations, or a core feature of an integrated asset management plan? And we'll just give you a minute. All right, the majority of the votes are in. Let's share the results.
For participants, we have a 5% cloudy at best, a 40% for minimally compliant with regulations, and a 55% for core features as the integrated asset management plan is already in place.
Thanks, Julienne. At this point, we'll go ahead and ask and answer questions. So let's make sure you get your last minute questions in there now. If for any reason you have to jump off, even though we are definitely ahead of time, just remember that you can email Tracy directly with any questions you have, and also that we'll be sending out a copy of the presentation as well as a link to the recording. You can expect that sometime tomorrow, and I'll make sure that I include contact information for both Julienne and Tracy. So, all right, let's get to questions. We've got one here. Sorry, bear with me. This is a little difficult to read on this little tiny screen, but will the new mega rule change any of the class location definitions?
Not that I'm aware of at this time.
Oh, well, that one was an easy one then. What else do we have? We have, will a copy of the slides be available for us to have after the show? Absolutely.
Yeah.
I'll send that out tomorrow. NYS has additional class location requirements. Does your software accommodate state requirements?
State additional class location requirements. I'm not aware of what the additional requirements are at this point. We'll go ahead and do a review of what they are. In most cases, the software is pretty flexible. It can be stringed together to adapt to majority of the regulation requirements and majority of the adjustments that need to be made. So we'll follow up with an email addressing those specific New York State class location regulations.
Okay, we have, how often do the operators usually perform field verifications?
That really changes from operator to operator, but in any case, the regulation does state continual surveillance. We do have a lot of major operators that go out monthly, and then a lot of other operators that have a much longer amount of time until they go out to do their field survey.
Do the PHMSA standards apply to any of the smaller 2-inch flow lines that we have in the oil field, even if these small diameter lines are in the areas which would be defined as HCAs?
If it's a small diameter pipeline, it's a transmission line, it should apply. It's probably a qualifying gathering line.
Can you specify a PIR instead of using calculated value based on pressure and size?
I'd have to follow up on that and verify that it can be calculated outside.
So yeah, we'll go ahead and we'll look into that, and then we will send you an email specifically with the answer to that question.
Okay, so go back to that. Can you go back to that question. So I didn't quite understand the question, but if you're asking the question as far as if you can add a tolerance to the PIR, there are some companies that call it a pedigree type tolerance. So basically what they do is they take the PIR and add additional buffer tolerance to that. Yes, it can be done, and yes, the software itself does do that.
All right. Says, please explain the difference between MCA and HCA.
A MCA, I believe, from the latest paper, is a moderate consequence area. An MCA is basically an area that is between your HCAs. So basically, it'll become a potential MCA if it's 1 to 5 buildings intended for human occupancy, where an HCA is currently at a 20 or more.
All right, it looks like that's all the questions we have for today. If we didn't get to your question, I will have Julienne and or Tracy reach out to you directly with an answer. If you think of one after you log off today, go ahead and reach out to them. Thanks for joining us this morning. We hope you found the content interesting. Make sure you keep on the lookout for an invitation to our upcoming webinar, in which Tracy better be here to deliver this time. But hope you have a great day, everyone.
Thank you.